Exercise 134, question 1. We've got two forces, 12 newtons and 7 newtons, and the 7 Newton force is acting at 50 degrees to the 12 Newton force. So we can draw it. It looks a bit like that. We've got to find the size of the resultant and its angle relative to the 12 Newton force. So if we assume the 12 Newton force is acting horizontally, it's up to us there, but along our reference line, which is 12 newtons horizontally, then we can take all angles from that point, from the positive x-axis. So we measure 50 degrees anti-clockwise from this positive x-axis. And we're after the size of the resultant. So the resultant is going to be some sort of line here. And we've got to find out what the size of that resultant is and the angle that that resultant makes with our reference, which is the horizontal positive x-axis. So the way to do this is to use the idea of finding the vertical and horizontal components of the forces. So if I take two forces and I add up the horizontal components of those forces and the vertical components of those forces, then the resultant will be this line here. So if I've got two forces, F1 and F2, F1 and F2, and this is the horizontal, and this is the vertical component of those two forces, then when I add them up, I basically just form a right-angled triangle. So the length of this side will be the vertical component of F2 plus F1, and then I can find, using Pythagoras, what the resultant is, and then using trigonometry what the angle is. So that's the basic idea, and you can have a go at it for yourself. Find the vertical and horizontal components of these two forces, the 12 Newton and the 7 Newton force. So I'll have a go at it now underneath. So if we first of all do the vertical components, well, for the 12 Newton force, that's acting horizontally. So the vertical component is 0 newtons. There's no force acting vertically. Horizontal component of the 12 Newton force, sorry, the vertical component of the 7 Newton force, well, if we take this force, it's acting at 50 degrees to the horizontal. That's 50 degrees. This is 7 newtons. And we're after, effectively, the length of this side for the vertical component of the force. And you can see that this is trigonometry, right-angled triangle. The vertical component of the force is the opposite side to this angle, and the 7 newtons is the hypotenuse. So we're using sine of 50 degrees equals the opposite, which is the vertical component of the force, divided by 7. So rearranging, the vertical component equals 7 times the sine of 50 degrees. Which equals 5.36. So the vertical component is 0 newtons, which is the vertical component of the 12 Newton force, plus 5.36 newtons, which is the vertical component of the 7 Newton force. So therefore the total vertical component FV equals 0 newtons plus 5.36 newtons. 5.36 newtons. Now we can do a similar thing to find the horizontal component. Well, for the 12 Newton force, that's acting horizontally. And so the horizontal component is 12 newtons. For the 7 Newton force, again, this 7 newtons acting at 50 degrees to the horizontal. So this time, right angle triangle, we're after this side of the triangle, which is the adjacent to the angle. So we use the cosine. So the cosine of 50 degrees equals the adjacent, which is the horizontal component of the force, over 7. So the horizontal component is 7 times the cosine of 50 degrees, which equals 4.50 newtons to 3 significant figures. So now we have a situation where the total vertical component, the total horizontal component, is going to equal 12 newtons plus 4.50 newtons, which equals 16.50 newtons. So now we can write our right angle triangle. We've got a total vertical component and a total horizontal component. So the total vertical component is 5.36. The total horizontal component is 16.50. And so we can now write our resultant in, which is this line here. And so completing the right angle triangle, this side here will be 5.36. And so we can now use Pythagoras to find the value of the resultant. And we can use trigonometry to find the angle theta. And so from Pythagoras, r equals the square root of 5.36 squared plus 16.50 squared. And theta, because we know the opposite and the adjacent is to do with the tangent, is the angle whose tangent is 5.36 over 16.50.